Hello guys, in this lecture I will discuss about the method of moment estimates for the normal probability distribution. And this is the lecture 4 of the series of method of moment estimation. We know that in normal distribution there are two parameters. One is mean, mu. Normally we denote that by mu, and the other is variance, sigma square. So we need to find the estimates for these two parameters using the method of moment estimation. So let's move to the formal lecture and try to find the estimates. So let's read the statement of the problem. Suppose x1, x2 up to xn is a random sample from normal probability distribution or normal population with mean mu, that is mean unknown mu and unknown variance sigma square. Find the MME of mu and sigma square. So this means that we have a random sample from normal population. Normal population means that population follows normal distribution. And we assume that the mean is denoted by mu, that is unknown, and variance is denoted by sigma square, that is unknown. So we need to find MME for the population mean mu and variance sigma square using the sample data. So what is given? Given as that xi is distributed normally with mean mu and variance sigma square. So this means that we can write the distribution function or the density function in case of the continuous probability distribution. So f of x with mean mu and variance sigma square is equal to 1 divided by 2 pi sigma e power minus 1 over 2 sigma square xi minus mu whole square. X has the range from minus infinity to infinity, mu has the range from minus infinity to infinity, and sigma square is greater than 0. Now we know that from method of moment estimation, you can see first lecture of the series. See lecture 1, not 4. This should be lecture 1 of this series, in which we presented the general procedure for the method of moment estimation. We need to solve mu r prime is equal to m r prime, where m r prime is equal to 1 divided by n summation I from 1 to n xi power r. This is general, this is the earth sample moment, which you can say raw moment. So m1 is equal to 1 divided by n. Suppose we replace r by 1. So the first moment is 1 divided by n summation xi, and then that's mean that m1, and this should have this prime, this also, and this also. So m1 prime is equal to x bar. So we also discussed already this in lecture 1 in detail. M2 prime is equal to 1 divided by n summation xi square, and we already discussed this in lecture 1. You can see lecture 1. I will give a link in the comments for this lecture, so you can see that lecture for detail. M2 prime is equal to x bar square plus s square. So we know m1 and m2. Now we need to calculate mu r prime. Now for mu1 and mu2, we can calculate that mu1 prime is equal to e of x. And for detail, again, I would like to recommend lecture 1 of the series. So this means that we need to calculate the expected value for the normal distribution, which means that is equal to x f of x mu sigma square dx, and which is further equal to this with the range of x, and definitely the range of x is minus infinity to infinity, x1 divided by 2 pi sigma e power minus 1 divided by 2 sigma square into x minus mu whole square dx. Okay, now what you need to do now, you need to do some substitution. Let's suppose let x minus mu divided by sigma is equal to t. You can assume some other variable, it does not matter. This means that x is equal to mu plus sigma t, and this also means that dx, because we will need this as well, dx as well, this is equal to sigma dt. So now we can put these values, and remember that the range of t is also from minus infinity to infinity, because you can see that x, you can see that x has a value minus infinity, t also has a value of minus infinity, fx has a value of infinity, t has a value of infinity. So the range is same, minus infinity to infinity, and you can write 2 pi sigma outside as well. 2 pi sigma, you can write x as mu plus sigma t, mu plus sigma t, and now this is equal to, because this is equal to x minus mu divided by sigma whole square, so this will become t square, because you can say this as a whole square, this you can write this is a whole, like here x minus mu divided by sigma whole square, so this is e power minus 1 divided by t square, and now dx is equal to sigma dt. Now you can write this separately for each term, for mu separate and for sigma separate. You will see that 1 divided by 2 pi sigma minus infinity to infinity mu, and with this e power minus 1 divided by 2 t square sigma dt, plus now 1 divided by 2 pi sigma minus infinity to infinity on sigma t e power minus 1 divided by 2 t square sigma dt. So I wrote this, in this step I wrote this whole function with mu once and then with sigma t. You can see now that this you can write 1 divided by 2 pi sigma, and you can write this mu and sigma outside because they are constant with respect to t. Mu sigma minus infinity to infinity e power minus 1 divided by 2 t square dt, plus you can write these things, I mean sigma and sigma t should be inside, 1 divided by 2 pi sigma minus infinity to infinity, and you can write sigma square because sigma and to sigma, and now t e power minus 1 divided by 2 t square dt. Okay, now after little simplification we will make this. Now you can cut this with this, so this is equal to mu divided by 2 pi minus infinity to infinity e power minus 1 divided by 2 t square dt, plus now you can cut one sigma with this one, so this is equal to sigma divided by 2 pi minus infinity to infinity t e power minus 1 divided by 2 t square dt. Okay, now this is, now you can see that you can use some rules of calculus here in this step. In this case, if you see this one, mu 1 divided by 2 pi minus infinity to infinity t square dt. Okay, so one is this function plus sigma divided by 2 pi minus infinity to infinity t e power minus 1 divided by 2 t square dt. The other is this function. So if you look at this function is odd function in this variable t, and you should know that for odd function the area and such type of limits which is minus infinity to infinity, and this can be specifically from minus 5 to 5 minus 10 to 10, the area or the integration of this type of for odd function you can say simply that is equal to 0. You can say that, for example, minus 5 to 5, an odd function I will say like x e power minus 1 over 2 x square dx, that is equal to 0, because you are calculating the area something like this. So this and this, that is equal to 0 when you are integrating this. You can see for further detail the calculus, the rules of the calculus. So this is from minus 5 to 5. Generally, this is specifically generally. So this is equal to 0, and we will solve this one. So this means that mu 1 divided by 2 pi e power that is equal to minus infinity to infinity e power minus 1 divided by 2 t square dt plus 0, which is equal to mu 1 divided by 2 pi minus infinity to infinity 1 divided by 2 t square dt. Now we need to solve this equation. This is already equal to 0. So now we need some other substitution, further substitution for this. And remember that, one thing remember that this is odd function and this is even function. Remember that for even function, you can make double the area. If the limits are from minus infinity to infinity, if suppose the limits are specifically, we can say the limit is from minus 10 to 10. So you can say that mu, and this is twice 2 pi, and now the limit should be from 0 to infinity e power minus 1 divided by 2 t square dt. See, please see calculus for odd and even function, specifically in terms of integration. So you will see these things, but how we can use these, implement these rules here. So now we need to some other substitution. Let's suppose 1 divided by 2 t square is equal to, suppose that is p. This means that t square is equal to 2p. This further means t is equal to 2p square root. Further, you can take integration of this because we will need dt here. So you can take integration derivative of this. This means that 2t, this is just derivative 2t dt, which is equal to 2 and dp. This further means dt equal to, okay, you can cross 2 dp divided by t, which is further equal to 2 dt equal to dp divided by 2p square root. So we know all the values. You can just put these values in this equation. In this equation, this will now equal to mu n to 2 divided by 2 pi and the limit will remain from 0 to infinity. You can check like I did above, and this is equal to now 1 divided by 2 square is equal to p, so this is equal to minus p, and now dt is equal to dp divided by 2 p square root. Now let's solve this. This is equal to mu 2 divided by 2 square root and pi square. We can write this separate, and now you can write this 2 here as well outside. 0 to infinity e power minus p, and now you can write this p power 1 over 2, so this p power should be minus 1 divided by 2 dp. Now you can cancel this 2 with this, and this is equal to mu divided by pi square root 0 to infinity e power minus p power minus 1 over 2 dp. Now you need to do some manipulation. I mean that you need to add and subtract something with the p power with the, this is not p, this is p, this should be p. With the p power you need to add and subtract something so that you can get a solution using gamma distribution. Okay, so I need to do something with this. Mu divided by 2 pi, and now 0 to infinity e power minus p power 1 minus 1 divided by 2 minus 1. I just added and subtracted 1. I did nothing, just I added 1 and subtracted 1. This is equal to now mu divided by 2 pi 0 to infinity. Now you can see that this is equal to p power 1 minus 1 divided by 2. This is equal to 1 divided by 2 minus 1 e power minus p dp. Now you can use gamma function. That is, I will do this in detail maybe in some other lectures, but I can just mention that 0 to infinity x power n minus 1 e power minus x dx is equal to gamma function of n. So I'm using this property of gamma distribution, and I can get, remember that this is not, 2 is not with this is only pi. So mu divided by pi square root, and now I can write this as 1 divided by 2 like this. N is equal to 1 divided by 2, so this is 1 divided by 2 gamma function. And in addition, you should know that 1 divided by 2 gamma function is equal to pi square root. This small thing you should know. So this means that mu divided by pi square root, and this is pi square root, so this is equal to mu. This means that mu1 prime is equal to e of x, which is equal to mu. So this is now equation 1, suppose. Remember that now we need to solve e of x square. Now e of x square, now because we need to find mu2 as well, and that is equal to mu2 prime equal to e of x square, which is equal to x square of x mu sigma dx. And this is further equal to and the range of x, which is of course from minus infinity to infinity, 1 divided by 2 pi sigma square e power minus 1 divided by 2 sigma square x minus mu whole square dx. Now you can write 1 divided by 2 pi, and this should not be sigma square here, this should be sigma minus infinity to infinity x square e power minus 1 divided by 2 x minus mu dx. Now again use the same substitution. I will write now the function in the proper shape. 2 pi, to avoid confusion, minus infinity to infinity x square minus 1 divided by 2 x minus mu, so that it can be easy in understanding, dx. So this is now x minus mu divided by sigma whole square. Now you can use the substitution. Put x minus mu divided by sigma equal to t. This means that x is equal, because we need these terms in these values in terms of x, so I need to calculate x, that is equal to mu plus sigma t. And remember that x take value infinity, mean that t take value infinity, x take value minus infinity, t take value minus infinity, so the range remain the same. And remember that dx, because we need dx as well, this is equal to sigma dt. Now just substitute these things and you will get a function now 1 divided by 2 pi sigma minus infinity to infinity x is equal to mu plus sigma t whole square and e power minus 1 divided by 2 t square, and dx is equal to sigma dt. Remember that we can write this, we have no changes, and you can write this sigma outside. Just write sigma outside, and now minus infinity to infinity. Now you can open this. This is the formula a plus b whole square. So mu square plus sigma square t square plus 2 mu sigma t, or minus 1 divided by 2 t square dt. You can now cancel sigma with sigma. 1 divided by 2 pi minus infinity to infinity. Now you can write three terms of this equation, one with mu square, the other with sigma square and t square, and the third one with 2 mu sigma t. So that write with these three, e power minus 1 divided by 2 t square dt plus 1 divided by 2 pi sigma square t square minus 1 divided by 2 t square dt. Remember the range is this, plus 1 divided by 2 pi minus infinity to infinity 2 mu sigma t e power minus 1 divided by 2 t square dt. So these three terms, I wrote these three terms because one with this mu square, the other is sigma square t square, and the third one is 2 mu sigma t. Okay, now we need to solve each of these terms. Okay, Now we can see that we can use again the property of odd function and even function to solve these terms. This function, as you can see, that this is an odd function nt. These all things are, you can write once more. This is 1 divided by 2 pi, and this is mu square minus infinity to infinity. So 1 divided by 2t square dt, and this is plus 1 divided by 2 pi. You can write sigma square outside, n minus infinity to infinity, and t square e power minus 1 divided by 2t square dt plus 2 mu sigma. These are all constant with respect to t. So minus infinity to infinity minus 1 divided by 2 t square dt. Now we can use the property of odd and even function and can solve these terms. So this is now odd function, and as we discussed already that this is equal to 0. The integration from minus infinity to infinity, this is equal to 0. And for the even function, you can twice the area or integration and start the limit from the mid, that from 0 to infinity. So you can see 2 mu square. This is because of the odd function. 2 pi 0 to infinity e power minus 1 divided by 2 t square dt plus 2 sigma square 2 pi square root 0 to infinity t square e power minus 1 divided by 2 t square dt. So this is equation 2, suppose. Now we need to solve each of these terms and then put the values and you can get the answer. So let's suppose this terms. This is e of x square. Now you can take this one, the whole one, 2 mu square divided by 2 pi 0 to infinity minus 1 divided by 2 t square dt. You can use the substitution as we did already and solve this. Put t square divided by 2 equal to p, and when t square is equal to 2p, this means that t equal to 2p square root. Again you can calculate the integration from here, that you can see that 2t dt equal to 2 dp, and now you can say that you can cancel 2 with 2, t dt equal to dp and dt equal to dp divided by t, and dt equal to dp divided by 2p square root. So just do this substitution and you will solve this equation. This means that this is equal to 2 mu square divided by 2 pi, the limit will remain the same, e power minus p, and now dp divided by 2p square root divided by 2p square root. Now you can see that 2 mu square divided by 2 pi square root, you can write 2 here in the denominator, and now this is 0 to infinity e power minus p power minus 1 divided by 2 dp. So now I can cancel 2 with 2, mu square divided by pi 0 to infinity. Now you can write p power minus this is p power minus 1 divided by 2 e power minus p dp. Again I will use the gamma function. Now as I did already that mu square divided by 2 pi, not 2 pi, this is pi, now this is only pi. So I will do some, this can be written that p 1 minus 1 divided by 2 minus 1. I just added and subtracted 1 minus p dp. And now you can do mu square divided by pi square root 0 to infinity and p power 1 minus 1 divided by 2, this is 1 divided by 2 minus 1 e power minus p dp. Now I will use divided by pi square root, and now this is the gamma function which I did earlier, and this is equal to 1 divided by 2 gamma function using the gamma distribution. Now this is equal to mu square divided by pi square root, and 1 over 2 gamma function is pi square root. So this means that this is equal to mu square. Cut this. So this means that 1 divided by mu square divided by 2 pi square root 0 to infinity minus 1 divided by 2 t square dt is equal to mu square. So we got one quantity solved, one terms of the equation 2, and now we need to solve second part of equation 2, which is this one. Now we need to solve this second part of the equation. Okay. Again, you can use the same substitution to solve this part. Okay, let's take this one. Now part 2. Part 2 is equal to sigma square divided 2 sigma square with 2 pi square root 0 to infinity e power minus 1 divided by 2 t square dt. Now again put t square divided by 2 equal to p, t square equal to 2p, t is equal to 2p square root. Now again use the same thing that you can 2t dt equal to 2 dp. Cut 2 with 2, dt equal to dp divided by t, and dt equal to dp divided by 2p divided by 2p square root. So you can use this and this equation in this part, which means that 2 sigma square divided by 2 pi 0 to infinity, the limit will remain the same, and t square, that is 2p, t square is equal to 2p, so t square is equal to 2p, and now e power minus, that is p, and now dt is equal to dp divided by 2 square root p. Now simplify this and you will get 2 sigma square divided by 2 square root pi. You can write this 2 here in the denominator and the square root, and 1 2 is here, so this 2 is here, and now 0 to infinity, this is p e power minus p, or this p should be minus 1 divided by 2 dp. Now simplify the things. So you can cut 1 2 with this, these 2. This is equal to 2 sigma square divided by pi. Now 0 to infinity. Now this p has power 1 and this has power p power 1 minus 2. So this is 1 minus 1 divided by 2 and e power minus p dp. Now 2 sigma square divided by pi 0 to infinity, and this will have now the p power as 1 divided by 2 e power minus p dp. And remember that we use the gamma function in which there as p has some power minus 1, p has some power minus 1 and e power minus p dp, then we can use the rules of the gamma distribution. You can see in the first part of this lecture. So for that purpose we need to do some add and subtract something. Pi 0 to infinity p power 1 divided by 2 plus 1 minus 1, because we need this minus 1 minus p dp. So we need this minus 1, we need to add also 1. 2 sigma square divided by pi square root 0 to infinity, and this will now equal to 3 divided by 2 p power 3 divided by 2 minus 1 e power minus p dp. So you can use now, again you can use the formula of the gamma function, that 2 sigma square divided by pi square root, and now this is now equal to n, which where I use the formula in the first part of this lecture. So this is equal to n, so you can write this as a gamma function, 3 by 2 gamma function. And remember that we need to expand this. Remember that suppose if I have a gamma function of n, I can write this n minus 1 and to n minus 1 gamma function. So this means that I can expand 3 by 2 gamma function is equal to 3 divided by 2 minus 1 and 3 by 2 minus 1 gamma function. Okay, so to do this, we can solve this. This is 2 sigma square divided by pi square root 3 by 2 minus 1 and 3 by 2 minus 1 gamma function. 2 sigma square divided by pi square root. So this is equal to 1 divided by 2 and this is 1 divided by 2 gamma function. Now you can cut this with this, and this is equal to sigma square divided by pi square root. And you know that we already discussed that gamma function of 1 divided by 2 is square root of pi. So this is, you can cut this with this, and this is equal to sigma square. So you can say that now 2 sigma square divided by pi 2 pi square root 0 to infinity t square e power minus 1 divided by 2 dt is equal to sigma square. So this part is equal to sigma square. The first part was equal to mu square. Therefore, we can say that this implies that E of x square, which is equal to mu 2 prime, is equal to mu square plus sigma square. Equation 3. Okay, now we have mu 2 prime, mu 1 prime, and we already have m1 prime, m2 prime. So now we can solve. Now mu1 prime is equal to m1 prime is equal to m2 prime, which implies that m1 prime is equal to mu, which we calculated, and this is equal to x bar, which implies that the method of moment estimate as x bar simply. Now m2 prime, mu2 prime, that is equal to, we just calculated, that is equal to mu square plus sigma square, and m2 prime, that is equal to x bar square plus s square. And you already know that the moment of method estimate of mu as x bar, so you can replace this with the x bar square plus sigma square, because this is known now, so we can replace this x bar square plus s square. So now you can cancel these two and imply that sigma square is equal to s square, and this is the method of moment estimate of the sigma square. So you can say that mu and sigma square, the method of moment estimate of mu and sigma square, or x bar and s square per normal population. So this is all about that how we can calculate the method of moment estimates for normal population. Thank you very much for watching, and see you in the next video. Ciao.